If we see a trig function like sine or cosine appear in a function where it's a product with another independent variable or a quotient, then we're going to have to combine our trig rules with our product or quotient rules. So let's try some. If we want to calculate the derivative of 5x cubed multiplied to sine x, I need a product rule. So to calculate f prime, I would need the derivative of my first function, 5x cubed, times the second function, plus the derivative of the second function times the first function. And if I evaluate each of the derivatives, then I can rewrite my derivative of f prime, as 15x squared times sine x plus cosine x times 5x cubed. Although this is technically a perfectly good answer for the derivative of f, most of the time you would like it factored because it's more useful that way. So let's get in the habit of practicing factoring our derivatives after we compute them. Looking at our coefficients, the 15x squared and the 5x cubed, we can see a common factor of 5x and x. So we'll factor out a 5x squared. That leaves behind 3 sine x plus x cosine x. So our derivative for this function f is 5x squared times 3 times sine x plus x cosine x. So in that case, we needed a product rule with our rules for taking the derivative of a trig function like sine. Let's take a look at this next one. This function has cosine x divided by 4x squared. And if we know cosine x has a derivative which is negative sine x, then we can combine that fact with our quotient rule. To find f prime for this function, I will do the derivative of my top function times the bottom function minus the derivative of the bottom function multiplied to the top function, and then that whole thing is divided by my bottom function squared. So the 4x squared gets squared again. Evaluating each of our derivatives and then rewriting our entire expression, we'll have negative sine x times 4x squared minus 8x times cosine x, all divided by 16x to the fourth power. And again, if you can factor, we should. So looking at the terms in our numerator, I see some factors here in common. Both terms have a factor of 4x, and both terms are negative. So we're going to factor out a negative 4x. So now we have that the derivative is negative 4x multiplied to x times sine x plus 2 times cosine x, all divided by 16x to the fourth power. But we can see that the numerator and the denominator have a common factor of 4x. And so we'll divide that factor off to give the best simplified answer, which is negative x sine x plus 2 cosine x, all divided by 8x cubed. So now we know that we can take derivatives of functions that are not only products of functions of x, but also involve trig functions.